Welcome to Module 3, Topic B, Lesson 7, Understanding Equations. This will be our first lesson in Topic B, which is to solve problems using expressions, equations, and inequalities. Okay, and these are things we've been talking about for a while now, but now we're going to look to understand them a little bit better. So, yes, welcome to Lesson 7. Okay, so this opening exercise here is going to illustrate why understanding equations is so important and why I have been trying to emphasize that in class as well. Let's go ahead and do it and you'll see what I mean. So here's the situation. Your brother is going to college, so you no longer have to share a bedroom. You decide to redecorate a wall by hanging 2 new posters on the wall. The wall is 14 feet wide, represented here, 14 feet wide, and each poster is 4 feet wide. You want to place the posters on the wall so that the distance from the edge of each poster to the nearest edge of the wall, those two places, is the same distance as between the posters, okay, as shown in the diagram below. Determine that distance. Now many of you, well not many, but some, have been resorting to processes that they are very familiar with. Okay, for example, if we know the whole wall is 14 feet and wide, we know these are 4 feet, okay, we could just subtract away 4 and 4. Okay, so if we subtract away this, same as subtracting away 8, we know that there's 6 feet left, and that's 6 feet. If we want to fill in 3 places, we need to divide that 6 feet by 3 to make sure that they are all even or equal, and we know that each one of those will be 2 feet. Okay? Now we can do it that way. Now if we only want the correct answer, we can do it that way. And in this case, we have the correct answer, and you might be happy. But more importantly to me is that you know how to use an equation or set up an equation to complete this problem. So for example, we can make it look more equation-like without actually using variables or our unknowns in the following way. So we can just look at it and we can so we know the answer already. So we can just look at, we can go 2 plus 4, because that's 2 plus 4 plus 2 plus 4 plus 2. Okay? We can set this up that way because that equals 14. Okay? This can also look like this. We have 1, 2, 3 2's. So we can do 3 times 2 plus 4 plus 4. Okay? And that also equals 14. We can do 3 times 2 plus 8. And that equals 14 as well. So of course this is all after the fact, when we already know the answer was 2. Okay, let's just go ahead and transfer that, every 2 there. Let's go ahead and turn every 2 in that list there into an x. X plus 4 plus x plus 4 plus x equals 14. Okay? So this is a way we could have proceeded right from the beginning, because we know 14 is on one side of that equal sign, because we need to account for the entire width of the wall. Okay? Our x's, of course, are our unknowns, because they represent these little bits here, which we don't know from the beginning. Okay? And then our 4's are what are given to us, okay? And those are here. All right, we could clean this up and combine like terms as we have done in the past, and we know we have 1, 2, 3 of those x's. So 3x plus 8, because we know about this, 4 plus 4 is 8, and that equals 14. So now we have a wonderful equation set up. And what makes it an equation? The fact that we have included an equal sign. Okay, this is a finite amount we're working with. We're working with 14 feet. Okay, there aren't many possibilities. There is only one answer for x at this point. We are trying to come up with what is called a solution. So we are not evaluating using an expression, but we are solving using an equation. Okay? All right. Now if we went ahead and went through with this, and we have done this already, we know what we need to do. We need to isolate, and we know the answer already, of course, but doing it as an equation, we need to isolate that x, which means get that x alone by itself on that left side. First thing to do is to add the additive inverse of positive 8. And there we have done that. And that gets rid of positive 8 on this side, but it makes this side now 6. So we have 3x equals 6. Now we're talking about the multiplicative inverse, and what we are actually doing is dividing both of these by 3. So we don't confuse that. Okay, dividing both of these by 3, which is the same as, we had 3x here, multiplying it by the multiplicative inverse or the reciprocal of 3. Okay, so this is exactly the same as doing this. Okay, and then if you do that, of course, 3, so that's going to equal x, and then 6 divided by 3 equals 2. And there is our answer. Okay? This is our answer using this equation properly. Okay. Okay, so in this next problem here, it says your parents are redecorating the dining room and want to place 2 rectangular wall sconce lights that are 25 inches wide. You can see that here. 25 inches wide, these 2 sconces, and along a 10 2/3 foot wall, so that the distance between the lights and the distance from each light to the nearest edge of the wall are all the same. Okay, so similar to the last problem, just using some different measurements. Okay, and design the wall and determine the distance. Now, first thing you'll notice, what does make these different is that you now have a rational number here, actually a mixed number, and then you have a whole number for both of these. Okay, so you're thinking, hopefully, the first thing you need to do, we've talked about this in the past, and you've probably talked about this many, many times in your math lives, but if we are going to compare these to this measurement to this measurement, we need to have them in similar units. Okay. Presently, they are in feet up here. This is in feet. Okay, and then these down here are in inches. So, decision number 1, decide which unit of measurement you will convert to. So if we go ahead and convert to inches, okay, we're going to need to take that 10 2/3 feet right here. We can use some algebra actually to figure this out. 10 2/3 would be the same as or equal to 10 times 12, okay, because we are looking at to convert to inches. That's what that 12 is standing for. Okay, 12 inches in 1 foot, and that's right here, the 10 part. Okay, because as we learned some time ago, a mixed number is a combination, or the sum in a sense, of these two. 10 plus 2/3. Okay, so we can take those two pieces and separate them out, which we have done here. 10 times 12, and then we have 2/3 times 12. Okay, and I put 12 over 1 because we're going to do some multiplication there. We multiply 10 times 12, we get 120. So that 10-foot part is equal to 120 inches. When we do our multiplication here, 2/3 times 12 over 1, we get 24 over 3, which is an improper fraction. And that improper fraction, 24 over 3, is equal to 8. Is equal to 8 right there. Okay? And actually this right here, I put 128, I'm going to put 120. So now we have 120 plus 8, which is 128. So this 10 and 2/3 feet is actually equal to, or equivalent to, 128 feet. Okay, so now that we have that conversion, let's go ahead and create an equation using all of these inch measurements. And again, I put feet here, this should be inches. Okay. Okay, so we have our unknowns right here, x. So how about x plus, then we have 25 plus another x plus 25 plus another x right there. That is all equal to 128 because we're talking inches now. Okay? That is our equation. Now, of course, we can simplify that equation by combining like terms. We have 3x's plus, we already have 50 inches accounted for, and all of that equals 128. So here is our handy-dandy equation. Okay, 3x plus 50 equals 128. We go through the steps to isolate the x. First thing to do, of course, is add the additive inverse of the 50 to both sides, and that is actually negative 50. So now we have 3x, because these cancel, equals 78. Okay, and then again we divide our 3x, or multiply by its inverse, inverse of 3, equals 78 over 3. Okay, and then, so this is x, of course, and that equals, looks like it's 26. So 26 inches, that's 78 divided by 3. 26 inches. Okay, so these right here are 26 inches. And if we convert that to feet and inches, you know there are 2 feet, 24 inches and 2 feet, and then 2 of those left over. 2 out of 12, which is also equal to 2 and 1/6 foot. Okay? In this case, though, if we were going to do this, and we really were going to do this at home, converting to inches would be much more preferable. Finding 1/6 of a foot is, well, of course, it's 2 inches, but finding 1/6 of a foot is not as practical, probably, as finding 26 inches. Now here's what it looks like when we use feet. If we're going to be using feet, we want to take our 25-inch measurements here, and we want to convert into feet. Now the way to do that is we're going to, of course, divide by 12. 12 is that magic number. And then dividing 25 by 12, of course you can make a fraction out of that, which looks like that. That says 25 divided by 12. And then we know that there are 24 inches and 2 feet, and then there's 1/12 left. Okay? So this is the number we'll use right now. So now we have over here, we have x again. We have 2 and 1/12. X, 2 and 1/12, and then x. Okay? And that's what we have right here. X plus 2 and 1/12 plus x plus 2 and 1/12 plus x. Again, simplified by combining like terms. We have 3 x's. And then we have 4, and I have 1/6. And the reason I had that highlighted before is that when I add 2 and 1/12 plus 2 and 1/12, I get actually 4 and 2/12, but I always want to simplify. As soon as I see a fractional portion that I can simplify or reduce to lowest terms, I want to do that to make it cleaner for me. So that's why I made this into 4 and 1/6. Now you get the right answer if you used it, if you use this as well. So it's not a panic if you don't. And then that all equals 10 and 4/6, which is actually the same as 10 and 2/3. Okay, because 10 and 2/3. What I saw here is I had 6 on this side, right here. So I wanted to make it similar. I wanted to make it 6 as well. So 10 and 4/6 are the same. Okay, so if I can get these fractional portions to be like fractions right from the get-go, it's easier for me as I move through the problem. Again, we get rid of the 4 and 1/6 here. Okay, trying to isolate x on the left side. So if we subtract it away from there, we're left with 3x. Over here, 10 and 4/6 minus, again, another good reason to have this in like fractions. And that's going to be, and this is easy too because this is 6 and 3/6. Okay? There may be occasion where I'd have to turn this into improper fractions before doing that, but I'm going to do that anyway. So, but anyway, that's the answer there, so that's this here. So now we're down to 3x equals 6 and 3/6. And like I said, I know I'm going to be dividing here by 3 or multiplying by the reciprocal, which is 1/3. Those are the exact same processes, okay? So I am going to go ahead and turn that 6 and 3/6 into an improper fraction, because improper fractions are our friends in algebra, okay? They help us divide much more easily, divide and multiply. Okay, so then I go ahead and I divide by 3x divided by 3, which is easy to do. That gives me x. And now I multiply my 39/6, which is my 6 and 3/6 over here, as an improper fraction, and I multiply it by the reciprocal of 3, which is 1/3, and again, same process. And then I multiply, I can do my cross cancel here, and that is 13, that's 1. Then I have 13 over 6, and 13 over 6, guess what? It's the same as 2 and 1/6 feet. So I got the same answer this way, converting to feet, as I got the other way when I converted to inches. Now these next pages, if you'll notice, we actually did all this work back here when we plugged in x for the spaces, the unknown spaces on the wall, and then we wrote an equation, and then, well, now they said they did y for inches. We just went ahead and did x both times. Okay. Now this last part here says what values of y, or let's say x because that's what we used, makes a second equation true. So let's just go ahead and plug one of our equations in, and that was this one right here. So we go ahead. So we had 3x plus 4 and 1/6. Actually, that's not. Let's use the inches one. So what do we have? We had 3x plus what do we have? How many inches was it? It was 25. So it was 25 plus 25, right? Equals what was it? 7. What do we have here? What did it come up with feet wise? We came up with 128. Okay, so we had that. So now they want to know, you're going to prove now, you're going to use one of these, you're going to actually plug these values in to see which one works, which one solves the equation or makes the equation true. Again, if we just boil this down to 3x plus 50 equals 128. So if we went ahead and plugged in, well, we know which answer is correct. So if we plug in 26, we know that 3 times 26 plus 50 needs to equal 128. And if we do 3 times 26, that is 78, plus 50, and that does equal 128. So that is true. You can see that if we plugged in either 25 or 24, we would not get the correct answer. Okay, so here we go. Here's an example. Here is the ages of 3 sisters are consecutive integers. Consecutive integers. The sum of their ages is 45. Calculate their ages. So we want to know all 3. Okay, so we're going to go ahead. I want to see what you can do with this. This is a very, very familiar problem, and one that kids struggle with because they don't really have a real strong sense of algebra when they're trying it. But if you try to solve these algebraically, you will see how successful you will be. So go ahead and do this first. Go ahead and use a tape diagram. Remember our tape diagrams to find their ages. Give it a whirl. Come on back. Now, you might have initially set up your problem like this here, your tape diagram, because this is the way we use tape diagrams primarily. We've used them horizontally with the different pieces of a sum connected. Now, I should probably just kind of clear up this idea of consecutive, and hopefully you have that cleared up already. Consecutive integers are, for example, 1, 2, 3. They are integers that come in a row. 9, 10, 11. Okay, all of these are examples of consecutive integers. Okay, so what differentiates one from the next, of course, is adding 1. I add 1 to 1 to get to 2, add 1 to 2 to get to 3. Okay, all right, that's that idea of consecutive. So hopefully you knew that, but something good to go over first. So I have represented it a few different ways. I represented the first integer as x right here, okay, and then the next integer would simply be x plus 1, and then the next one would be x plus 2, okay, and I know that they're all going to add up because they told me here that the sum of their ages is 45, so all of those together is going to equal 45. Now I could also represent it this way if I look at it kind of vertically, horizontal for each integer, but vertically we could look at it, because what I've done here is I have x here, and then I have x, and then I've added 1 to it, so that's x plus 1 as well. And then here I have x plus 2 1s, which is x plus 2. Okay, so either way I have my x values, my variables, and I have my numbers. Okay, so both of these, if you'll notice, you could put 3x plus 3 equals 45. Okay, and we can look at where those came from. Here are our 3 x's, 1, 2, 3, in this diagram. Here are our 3 here, 1, 2, 3. Here is our 3. We have 1 plus 2 is 3, or 1 plus 1 plus 1 is also 3, and all of those equal 45. Okay, so we can set up our equation to look just like that, and then we can solve for x, and when we do solve for x, we will know the first sister's, or actually the youngest sister's age right here. Okay, so let's go ahead and do that. I know you know how to do that. 3x equals 42, and you can see how I did that here. I just added negative 3 to this side and negative 3 to this side. Okay, 3x equals 42, and then x equals 14, right, because 3x divided by 3 is x, and then 42 divided by 3 is 14. Okay, so now I know that the first sister, or the youngest sister, is 14. The next sister is this x plus 1, so she's going to be 15. And the next sister is this x plus 2, which is 16. That's 14, 15, 16, right? If I add all of these up, these should equal 45. And then, that's right, that is 15, carry the 1, and that is 45. And the fact that they do match up when you plug them in, that makes the equation true. Okay, so our equation in tape diagram form transferred to equation form and then solved. X equals 14, and again, when you solve a problem like this, you solve for that x and then you plug in that x wherever you have an x. So x plus 1 there, 14 plus 1 equals 15, x plus 2, 14 plus 2, 2 equals 16. So we have a 14-year-old, 15-year-old, and a 16-year-old. Okay, so once again, like the previous problem, we've pretty much already done this all together over here. We've gone through just about everything that these questions are asking us. All right, and we've actually determined that it was a solution to that problem. Okay, so now let's go ahead and move on to the exercise here. Okay, and in this exercise is going to ask you, it's going to give you a few scenarios here, and we want you to go ahead and let's see what they want you to do here. I want you to complete the following exercises and discuss the solution. And of course you would discuss the solution to the class if we were in class, but you can go ahead and discuss the solution to your teacher, to your parent teacher, or to someone nearby. Okay, so so right here we'll do A first, and if you want to keep coming back, I'll complete A, B, C, and D one at a time. So it says Sophia pays $19.99 membership fee to an online music store. Okay, so remember that $19.99. All right. So A asks you here, it says, if she also buys 2 songs from a new album at a price of 99 cents each, what is the total cost? What is the total cost? Figure that out in whichever way you need to. Okay, if you take a look at it here, I just went ahead and did it in a semi-algebraic way here. I have my $19.99 membership fee, and then I have 2 times 99 cents to account for my 2 songs I bought at 99 cents each. Carry that down, $19.99 plus $1.98 equals $21.97. Okay, so the next part asks us, and now you can see something has changed a bit. If Sophia purchases N songs for 99 cents each, now you're going to write an expression. You're going to write an expression for the total cost. So we're going to use N songs. And you can see the difference here. In A, we have a total. We know it's 2. Now in B, changed a little bit. We have an unknown. We have a variable N. So just go ahead, no solving, of course. Just write an expression for the total cost. So as you can see, that's a pretty simple task. It is not an equation yet. There's no solution. There is just an expression, and that expression would be written as such: 0.9. Oops, didn't mean to do that. 0.99n plus 19.99. And of course, that 19.99 comes from here, the membership fee, and then the 99 cents, of course, comes from here. They cost 99 cents each. And the n right next to it means we're going to multiply that 99 cents by the number, whichever number we choose to put in there at any time. Okay. Right now we are just we have an expression only. Okay, as you see, no equal sign is needed at this point because it is just an expression. Okay, so C says Sophia's friend has saved $118 but is not sure how many songs she can afford if she buys the membership and some songs. So now we're going to apply our expression, use the expression in part B to write an equation that can be used to determine how many songs Sophia's friend can buy. Okay, so now we are talking about an equation, something very, very different. And another key number we have is the $118. We of course have our expression here, so go ahead and put those together to write an equation that can be used to determine how many songs Sophia's friend can buy. Just write the equation, don't solve yet. And as you can see, that was another simple task. What we have done, we've just combined the two elements. We have our expression right here, which came from B, right there. And we have our total, which came from this problem right here. Okay, we know she has $118. The idea is how much can this $118, or how many songs could it buy? Okay, because these two sides have to be equal. All right, so that's our equation. So in D is going to ask you right now, using the equation. So again, you can see a step-by-step process. Using the equation written in part C, can Sophia's friend buy 101, 100, or 99 songs? So what you're going to have to do is go ahead and test those until you are successful. Plugging in 100, 101, 100, and 99 until you are successful. Okay? So a good way, if you're given a problem such as this, where you have three to test here, is to maybe test one in the middle, which I did. I tested 100. And when I did test 100 by plugging it in, I substituted, of course, 100 for n, and then that's 99 cents, 0.99 times 100, of course, is 99. And then I add my 19.99 because that's part of our equation right there. And then I get $118.99. So I can see how that compares. She only has $118. If she were to buy 100 songs, she would need $118.99. So 100 does not work. Okay, but I could also look at my options, and I know if 100 doesn't work, I can't buy 101. So I know that 99 songs, she can buy 99 songs with her $118. Okay, here's a few more pieces of relevant vocabulary. And again, we've been hearing many of these over and over again. The first one here they want to talk about here, this variable. And a variable is a symbol, so just a letter that represents a number, i.e., and it is a placeholder for a number. Okay, in this case we had n as our variable, and it was used as a placeholder for any number. Okay, so it stands for a number, and in this case we tested a few numbers. Well, actually only tested one number, and that was 100. We found out that that solution did not work, so we knew where to go. Now in some cases you may have to test the other two as well before you actually get to the right answer, but in this case it was pretty obvious once we tested 100, and it failed for being too high. Okay? An equation, of course, an equation is a statement of equality between two expressions, and that just means it contains an equal sign, and that equal sign always means that what's on one side is equal to what is on the other side. In this case, as you can see, this was not equal right there. A number sentence. A number sentence is a statement of equality between two numerical expressions. Okay, so 1 plus 4 equals 5. Okay, that's a number sentence. Here it's not an equation necessarily because there aren't any expressions, but there are numerical. These are strictly numerical expressions. Okay? Solution. A solution to an equation is with one variable is a number that, when substituted for the variable in both expressions, makes the equation a true number sentence. Okay? And again, very very specific here, this solution to an equation with one variable in this case, okay, is a number that, when substituted for the variable, because sometimes you're going to have multiple variables, you're going to have x and you're going to have y, and maybe several others, but in this case we have one variable we've been working with, and for example here was n. Okay, when we substituted 100 for n, okay, it did not work out because It did not equal 118, it equaled 118.99, so that was not a solution. If we went ahead and plugged in 99, we would find out that it did work, therefore it would be a solution. So it makes the equation a true number sentence. Okay, so here we are at our lesson summary, and I'll just read this here while you read along with me. In many word problems, an equation is often formed by setting an expression equal to a number. Okay, this is, again, it's not always going to be the case into the future in algebra, but very often for us and for our purposes right now, most of our equations will be set to equal a number. Okay, so for example, we had 3x plus 50 equals 128. Okay, early on in this lesson. All right, 3x and 50 and 128. So it's going to actually have that number on that far right side. Okay. To build the expression, it is helpful to consider a few numerical calculations with just numbers first, and that's kind of what we've done here. For example, if a pound of apples costs $2, then 3 pounds costs 6 times 2 times 3. 4 pounds costs 8 times 2 times 4. And n pounds cost 2n dollars. Okay, so if you want to find the cost for a number, any number of pounds, you can add your variable. Okay, your variable there. If we had $15 to spend on apples and wanted to know how many pounds we could buy, we could use that expression that we just created here, 2n, to write an equation, 2n equals 15. Okay, so we have 2n equals 15. So this is assumed that both of these sides are going to be equal, and there's a way to make them equal. You could find the answer 7.5 pounds this way, because you could just put 2n, divide that by 2, and then divide 15 by 2, and you would get n equals 7.5, or 7.5 pounds. Okay. Now, to determine if a number if the number is a solution to an equation, you substitute that number into the equation for the variable and check to see if the number sentence is true. If it is true, then this number is the solution to the equation. For example, we could look at the one we just did here. We had 2n equals 15. If we substituted n, 7.5 for n, that's saying that 2 times 7.5 is equal to 15, and it is. Okay, so that solution is true. Alright, well that is your introduction to topic B, lesson 7. Do your problem sets, do your exit ticket, and get in touch if you need any help.